Hi students, this is the third applications. See the once the application what is given here. A ladder of mass m and the length is given capital L resting on a level floor is lifted and held against a wall at an angle theta with the floor. We need to find out here work done by the gravitational force. Applications I'm discussing about the work done only, that's why we need to find out here work done by the gravitational force on these applications. According to this application, I will draw the diagram. Once we can see how I am drawing this diagram according to these applications. So first I will take one floor. This is the floor here. Right, so on this floor what happened, one ladder is there. So now see, this is the ladder. This ladder is initially on the floor like this. This is the ladder. Initial this ladder where it is there resting on the floor. After that, this ladder I will attach the first end. This is the first end I am considering. This is the second end I am considering. Now I will lift it this ladder. The first face or the one end of the first one end of this ladder I will keep against the vertical wall on this diagram. Means we have to see here how I will draw this ladder on the wall. In this case, the same wall what I drew here before, that one I will keep against on the vertical wall. Now you can see like this, like this. Now this is the ladder against the vertical wall. I kept this. Right, this is the ladder. Right, the total length of this ladder is given here capital L. The length of the ladder is given here capital L, and a mass is given here m. This is the small m is the mass of the ladder, capital L is the length of the ladder here. So this is the two, this is the floor first one, and the second one is the wall. Now this is the ladder, means the total mass of the ladder is located at the exactly in the middle position. Similarly, the application number 2, what I discussed there, the total mass is located exactly at the center of the rod because I took the uniform rod. Now, similarly here also I am taking ladder, mass is located, the total mass is located at the center of the ladder. So here I am taking from the center of the mass to the on the vertical line. If I consider the height is, I am considering in this case h. And one more thing I forgot to here to draw the theta in this case. If you observe in the question, angle theta with the flow, means this ladder is making some angle theta with the flow is theta is like this. So from this position to this position here, the ladder length is because exactly the mass is at the center, means the length here is L by 2. There is a L by 2. Now I am taking this from the center to this one. We can see the diagram. This is the ladder. This is the length is L by 2 because this is the center of mass is locating exactly at the center, and this is the starting point, and this is the h, and this is the angle is the theta in this case. Okay, so the main aim of this application is work done by gravitational force in this case. So we can see here work done formula is W is equal to, you know that, F vector dot S vector, means here dot means cos theta, then Fs cos theta. Here already we know that the theta is the, this one, theta is the angle between force and displacement, this one. So here force is nothing but what type of force? Gravitational force. Gravitational force is nothing but mass into g. But here S is nothing but displacement. How much of the body is moved? We can see initially the ladder is first side is there on the floor, but from the floor, this is the floor, from here to here we raise it, that is the height. But we are considering from the center of the ladder, means the height is here h. So I am taking h in this case. Height is the h. In the place of displacement, I consider in this case h. Next, cos theta. Theta means I discussed now, theta is the angle between force and displacement. Now we can see force is the gravitational force. The gravitational force is acting vertically downward, vertical downward gravitational forces, and the ladder is lifting to upside, then it is the height will be upward. Now the angle between these two here, height and display gravitational force is the 180 degrees. So here I will take 180 degree instead of the theta. So right, you know that cos 180 value is -1. So minus m into g into h. Work done, I got the formula here. Work done by the gravitational force, I got it, W is equal to minus mgh. So what is the height in this case? So maybe sometimes they will ask this height in terms of length also. Then we can see in this case, in this diagram, if you observe very carefully, how to find the h value, means here you can take the sine formula. Sine theta formula is opposite direction divided by hypotenuse. Here opposite is nothing but here h, and hypotenuse is nothing but L by 2. Then finally h is equal to, you can take the L by 2 cross multiplication, then L by 2 sine theta. Now the final answer is W is equal to nothing but work done by the gravitational force minus mgh. In the h place I am considering mgh place I am considering L by 2, 1 minus cos theta. Sorry, this is wrong, not mgl by 2 cos theta. I think minus mg, I think h I found there, L by 2 sin theta, L by 2 sin theta. This is the work done by the gravitational force if you take the ladder against the vertical wall in this case. Thank you so much.